Okay. And last class we discussed about displacement reaction. Displacement reaction. Okay, so I said already. So to understand this, first you should know something called reactivity series. Reactivity series. So what is the meaning of reactivity series? Means that it is an arranging aluminium. Aluminium. Next we have zinc, and after we have iron, and after we have lead, hydrogen, and we have copper, mercury, silver, Ag, and Eu. So this is a reality series. By this series, we will come to know which is more reactive metal is potassium and least reactive is gold. So as of given metals, don't think that in all the metals potassium is more reactive and gold is less reactive. So generally, we know periodic table is most reactive is cesium. Okay, remember. Okay, so now the given reaction like copper sulfate, which is blue in color. Okay, this copper sulfate, if you're adding iron, iron is where is iron more reactive than where is copper. So iron is more reactive than the copper. That's why displacement reaction is possible. FeSO4, FeSO4 plus FeSO4 plus copper will be formed. Similarly, this color is green color. After we discussed about for FeSO4, if you're adding copper, so copper, this reaction is not possible. You can say no reaction because what you can say, copper is less reactive than what's that? Less reactive than the iron. That's why the reaction is not possible. Okay. Now see. So some other reactions you can take. Example like take copper chloride, Cu2, Cl2. For this one, if we're adding iron, so I can expect FeCl2 or FeCl3 will form and copper will form separately. Also, generally, copper compounds are blue in color, bluish green. We can say bluish green. We can say this will be the pale green. It's pale green because of formation of iron chloride number. Okay, iron chloride. So I think iron chloride will be in yellow in color. FeCl3. That is okay. This is about displacement reaction. Let me discuss about one more kind of reactions. One more kind of reaction. Generally, this Displacement reactions are, remember, exothermic in nature generally. And the next one is anything but double displacement reaction. Double double displacement. Double displacement reaction. So here what happens here? Here you see here two salts will be there. There only one salt. Here two salts are there. Two salt solutions. Remember. So what do you mean by solutions? Already I said solute, solute plus solvent. Solvent gives solutions. They given here aqueous solution. Suppose I give an example of, if I taken the example of barium chloride solution, aqueous solution. If I written here aqua means solution, it is solution means the salt is dissolved in the water. Barium chloride and sodium sulfate Na2SO4. This is aqueous solution of sodium sulfate mixed each other. So in that time, what happens here? See, sodium forms positive ion, sulfate form -2. So we couldn't have a -1 and we have a positive. So cation may replace means this salt can exchange those ions. Cation exchange or anion ion exchange can be possible here. So if I take sodium and chlorine will form sodium chloride salt, which is aqueous solutions, and again we have barium sulfate. This barium sulfate is a insoluble substance. It's a solid substance. Okay, so this is a double displacement example. One more example I take last class we discussed. I think PbNO3 taken twice, which is a solution aqueous solution plus to be made to react with potassium iodide, which is also aqueous state. So both will react and they form lead iodide. Lead iodide, which is an insoluble solid. Okay, plus potassium nitrate KNO3 solution, aqueous solution. So here are insoluble substances, sir. Okay. So this kind you can see here, what happening here, positive form plus 2 response NO3 minus 1 K plus and I minus 1. So here cations are going to exchange, cation to cation exchange or anion type. Both are not possible because both are possible again same reactant will get. That's it. Here you see here barium sulfate is white color insoluble substance. Similarly, lead iodide PbI2 is a yellow color insoluble substance. Okay. Again, this double displacement reaction based on the type of products. Based on type of products, we are going to classify in different way. You see here in this cases, insoluble substance is formed. Insoluble solid is formed. Then this kind of reactions are called precipitate precipitation precipitation reaction, and this insoluble substance is called precipitate. We call precipitate. Remember. Okay, precipitate reaction is called precipitation reaction. Similarly, here also lead iodide is formed. It is also called precipitate. Precipitate, which is precipitate here, sir. PbI2 is precipitate. Okay, this reaction is called what reaction, sir? It's also called precipitation reaction. So what do you mean by precipitation reaction, sir? It's an double displacement reaction where one of the product is what, sir? Insoluble solid. Such kind of double displacement reactions are called what, sir? Precipitation reactions. Okay. Anirudh. Anirudh, reduction means nothing but addition of electron, we can say, or removal of oxygen, we can say. So from the substance, if you are going to remove the oxygen, then it is called reduction. Removal of oxygen, we can call reduction, or removal of hydrogen also, we can say. Addition of hydrogen or removal of oxygen is called reduction. So similarly, addition of electrons also we can say it's an reduction. Okay. So removal of electropositive element also is called reduction. That we explain. Okay. So see here, Anirudh is asking some question. See, suppose we have a Fe2O3. For this one, if you're adding aluminium, it forms Al2O3 plus it forms Fe. So now see here, from here to here, what I can say, I removed the oxygen. So can I say here you can see Fe without oxygen and the Fe is with oxygen. Is there? So this here you can call as a removal of oxygen, which is called as reduction. Okay, or else simply you see here you can see in this compound Fe have state of +3 and O have -2 state, and here you see Fe is elementary form, its oxidation number is 0. So you can see decreasing in the number also is decreasing in the charge is also called, like suppose it is a 0, it is on +1, it is on +2. On this side you see here -1, -2, -3. Now see earlier Fe was in Fe +3 state. Okay, here right hand side you can see it is in Fe is in the form of Fe +3. If I'm going to remove the electron, I'm going to remove the electron. So not removing electron, we are adding electron. Fe +3 is there. So in elementary form, it is getting Fe. Elementary form means oxidation state is 0. This is called reduction. So we can say removal of oxygen is called reduction, or we can say addition of hydrogen is also called reduction, or we can say addition of electrons also is called reduction. I hope you got the clarity about reduction. So anyway, let me discuss about concept. So I think we discussed about we are discussing about double displacement reactions. Again, I'm explaining here. Please try to understand. Double displacement reaction is a reaction. So here we can remember there must be an two salt solutions. Why we need solutions are actually solutions means remember ions are there. Ions will be formed in solution. Suppose if I have a copper sulfate salt, think like I have a copper sulfate salt, and I have a one more salt, think like we have a barium chloride salt. I'm not taking solution here. What happens here, ions will not form here. If ions are not formed, then displacement, this exchange of ions will not take. That's why it should be salt solution, remember. Okay, now see, if I take an lead nitrate solution PbNO3 taken twice. So aqueous AQ means remember solution. Plus we taken potassium iodide. Okay, it is also aqueous solution. You see here. See, lead will form lead +2 ions, and NO3 means -1, and potassium will be +1, and iodine is -1. So then exchange will take place here. So what happens here? Potassium ion will come here, they will displace the lead, and lead will get the place of potassium. You can say exchange of ions, double displacement reaction, nothing but exchange of similar ions. Again I'm saying, again I'm quoting word similar ions. Okay, not different, means positive ion exchange is possible, or negative either this is possible or this is possible. These two things, both things are not possible. Okay, now see, you'll get what's a PbI2 plus I'll get potassium nitrate. Okay, so again here basing on this is an insoluble substance, yellow color insoluble substance. This insoluble substance is called precipitate. Precipitate, and this reaction is called precipitation. Precipitation reaction. Okay, double displacement reaction only. Again based on the what kind of products are formed. Okay. Now see one more type of double displacement reaction is that suppose if I taken the acid, just a minute, staying time I think so. Any other doubt, Anirudh? No, see here. One more type of double displacement reaction here. I'm taking here acid. Okay. I'm making react with base. They forms salt and water. Salt and water. This kind of reaction is also called double displacement reaction. In that salt and water is formed, it is called also called as neutralization. Neutralization reaction. Okay, suppose here see acid are taking HCl and base is NaOH. Here also hydrogen ions H plus and Cl minus will be there, Na plus and OH minus. Both will exchange. Then what happens in the place of sodium? I can say HOH is there, and here what we can say NaCl. So we can H2OH second written as H2O water, and here that NaCl. This is salt, right? See, salt and water is formed. That's why this kind of double displacement reaction is also called a neutralization reaction. So you can take other things also. One more example, we can take say the acid name. I can say sulfuric acid H2SO4 is that. So they will take KOH, potassium hydroxide. I will take calcium hydroxide base. I will take, and I will take sulfuric acid H2SO4. And here also what happens you see here. Here you see again here what potassium sulfate will form K2SO4 plus H2 will form here. And here also calcium sulfate CaSO4 plus H2O. So these kind of reactions, double displacement reactions, also called what sir? Also called neutralization. Neutralization reaction they will call it. A double displacement reaction in which salt and water will be produced as what is called neutralization reaction. Okay. Any other questions? Now, after main important concept we can say, so this is also important somewhat. They given here, and after this one they given about something called redox reactions. Okay. Redox reactions. Here I should know certain things. Okay. So they given redox reaction. First you should know what is the meaning of oxidation. Oxidation means remember oxygen. Oxygen addition. Oxygen addition they're called as what's that? Oxidation. Okay. So some substance is there. Suppose example even for copper, just on eating on the China dish, they are getting copper oxide. Copper oxide. This is brown color metal. Remember. Example they'll ask X is brown metal means copper. Copper oxide turns into what's that? Black color will be the color of copper oxide. Okay. So now what we did here, sir, here to use here to here, copper we can say there is an oxygen which is added to the copper. So this process is called oxidation. Similarly, from the copper oxide, suppose if we have this is a process, we'll get copper plus H2O, copper plus H2O. So here to here you can see here to here what happens here now? Now there is a removal of hydrogen here. So there is not removal of hydrogen. For hydrogen we added oxygen. So it is called we can say this process hydrogen undergone the oxidation. In this process the copper from copper we remove copper also we remove oxygen. It is undergone the process called reduction. Okay. Generally in this process you should know they'll ask the questions. First one is which substance is undergone substance substance undergone the oxidation. Which substance are, we can say, copper oxide undergone which process of reduction. Similarly, you can say hydrogen undergone which process of oxidation. And remember, which substance is undergone reduction is called oxidizing agent. Okay, oxidizing agent. And substance which is undergone oxidation is called reducing agent. So reducing. So there is an four things will be there. You should remember. One is which substance undergone reduction, which substance undergone the oxidation. So you can see in this process, copper oxide. You can see by this one I can state that copper oxide reduced reduces towards reduces to copper. See, many children what they will do, they will write the copper. Copper is not reducing, copper oxide is reducing. Copper oxide reduces to copper. Okay, similarly, now what we can say, hydrogen oxidized. Hydrogen oxidized towards oxidized to H2O. This you should remember. Similarly, copper oxide reduced to copper. That's why it is copper oxide is what's a oxidizing agent. Oxidizing agent. Similarly, if I taken the hydrogen is called undergone which process of oxidation. That's what is called reducing agent. So remember here, it is very easy to remember. First, you should not list from where to where oxidation is taking place, where to where reduction is taking place. First, let me discuss about oxidation, okay, and we can discuss about reduction. Okay, here you can see this is addition of oxygen, removal of hydrogen, removal of electrons. Okay, similarly, reduction means removal of oxygen, addition of hydrogen, and addition of electrons. This is remember. Or we can say increase in charge. Increase in charge is also called as a oxidation. You can say decrease in the charge is also called as a reduction. This you should remember. After, let me see the example now here. Suppose if I have a what I have, if I have suppose magnesium plus oxygen gives rise to what's a magnesium oxide. In this process, first what I can say, magnesium oxidized, magnesium oxidized towards a magnesium oxide. Okay, similarly, what I can say, sir. So oxygen reduced reduces towards a magnesium oxide. So how it is possible, sir? Is here. Similarly, what I can say, magnesium is what, sir? Magnesium is reducing agent. Mm, oxygen is what, sir? Is an oxidizing agent. How it is possible? You see here, from here to here, elementary form is zero oxidation state, and this is zero also. From here to here, you see, from here to here, this is charge minus two. This is having charge what's a plus two. So now we can see, can already suppose this is an zero plus one plus two. This will be plus three, and so on. This is minus one. This is minus two, and so on. This side, if this number is decreasing, is called what's a reducing, you can say. Suppose this is increasing in charge, is called oxidation. So now we can see magnesium is an which process. Magnesium is 0 to positive plus 2. It is called what's that? 0 to plus 2 means here to here. It is undergoing this process of oxidation. Similarly, you see elementary form oxidation state of oxygen is 0. It is now minus 2. So 0 to minus 2, which direction it is moving is a reduction. So in this way we can understand which substance is undergoing oxidation, which substance is undergoing reduction process. Now see, if they given an exercise question, they given lead oxide plus carbon is equal to carbon monoxide plus lead. So now we see here, this is plus 2, this is minus 2, this is 0, this is what we can say minus 2, then it will be n plus 2, then it will be n what's that? It will be n 0 it is. Okay. Or simply we can say here what happens? Here I remove the oxygen, so we can say it undergone what's a reduction. And here what I can say it is there is an addition of oxygen, so we can say this process oxidation process. Okay. Now see I can write a statement. Lead oxide is reduced to what's that? Reduced to lead. Similarly, I can say carbon is oxidized towards to carbon monoxide. Okay, now see which substance undergoing reductions are lead oxide. So we can say lead oxide is called as a oxidizing agent. Okay, similarly, I can say carbon is what that is reducing agent. Reducing agent. Okay, let's remember. It's about oxidation reduction, oxidizing agent and reducing agents.